All right, so this is going on page 77. When we're done, we still have our little models that we can look at. Number 1 says to consider a region R bounded below by the curve of f of x equals x squared minus 1 and above by the curve g of x equals x plus 1. Find the area of region R. Is this something we've already done? Yes. It's just telling us to find the area. That's it. We're finding the area. Okay? So I'm going to, in order to find the area, I need to know which one of these, let's see. This one, is the blue one f of x or g of x? G of x, because it's a line, right? And the black one is f of x. Okay. All right. So x squared minus 1, and then what are we going to do with these? Subtract them, top minus the bottom, so g of x minus f of x, and all we do is subtract them. And we're done? We have to, bless you. I have to do what after I subtract them? Integrate them, right? I'm going to integrate them, right? And I'm going from what to what? To 2. Okay. So I'm going from negative 1 to 2. Do I have everything written correctly now? No. What do I need? dx. Okay. Cannot forget your dx. Okay. So that means this gives me the integral from negative 1 to 2. G of x is x plus 1 minus f of x, which is x squared minus 1 dx. So can I simplify that a little bit? Integral from negative 1 to 2. So that would give me a negative x squared plus x, then what? Plus 2 dx. Right? Okay. Any questions about that? Now, can you actually integrate that? Yes. So integrate that. See what we get. If you were doing what's called a definite integral, meaning you're going to get a number, you integrate, we put the line, and this is where we're going to evaluate it to, right? Do we substitute in the 2 first or the negative 1? The 2. So then this is going to give me negative 2 cubed over 3 plus 2 squared over 2 plus 2 times 2. Can I stop here? Yes, then stop here, okay? When I was grading your FRQs, there was, I've only gotten through number 1 yet. I don't even know if I did everybody's number 1, but that was with a Riemann sums. And you can just set it up, and then you can stop. Some of you set it up, went to actually figure out what the number is, and your number's wrong. And then that made you lose a point, where if you had just stopped, your numbers would have been fine. And then some of you found the number and it was correct, which is fine. But it's when your number's wrong that it ends up hurting you. Okay. All right. But I will tell you, if we simplify, we're not done though yet. I said we can stop here, but we can't really stop here, right? Because we got to subtract the other. And I get negative times negative 1 cubed over 3 plus negative 1 squared over 2 plus 2 times negative 1. Yeah. So no, you couldn't stop where I stopped. Now you could stop. Yeah, sorry. Then I'll just tell you you'll get 9/2. Okay. And this was the area under the curve, so this is units squared. Okay. Everybody okay with that? All right. So now we're going to look at what happens when we want volume. So we're going to consider the region R below, bounded by the curve, same region. Find the volume of the solid formed by square cross-sections perpendicular to the x-axis. So that means I'm going to have a square that's perpendicular to the x-axis. And so it would look something, except a whole lot better. Something like that. You got to pretend like that's 3D, right? That it's standing up off the board. I had one of those things in my hand. So if you pretend like this is a square, it would be looking like this, right? Just like what y'all have in front of you, okay? And then I know that if I want the volume, oh my gosh, that's big. Okay. There we go. That right there, how do I find that? That purple line that would be like the base of the square, the side length of the square. I want the distance from here to here, right? Yeah. So just subtract the y values, right? You just subtract the y values. That's all I have to do. Does that make sense? Okay. So we have a square. How do you find the area of a square? Base times height. So for a square, it's really just side squared, right? Area of a square is side squared. So because all four of these side lengths are the same. So to find the side length, you told me I just subtract the y values. Does that make sense why we would do that? Okay. So these are my y values, right? So once again, I would just do the top minus the bottom. So that is going to be, that means this s here, oh, I'll put an equals, let me put the s first, that would help. S here equals g of x minus f of x. You agree with that? And g of x is x plus 1 minus f of x, which is x squared minus 1. And that's going to give me negative x squared plus x plus 2, which is what we integrated up there just a second ago. Okay. Now that's the area of one square. I want all of those infinite amount of squares that I can stack in here to create my volume, right? So that means I want every square I can get from negative 1 to 2. We wanted area here, so we integrated the distance between the two. I want volume here, so if I want volume, what do I integrate? The area. So I'm going to integrate the area of these, which means I'm going to integrate, I'm still going from negative 1 to 2. And if this is my side length, my area formula is s squared. So this is one side length, right? Just the g minus x, or g of x minus f of x. So that means negative x squared plus x plus 2 squared. That's my s squared dx. Okay. Everybody okay with that? So let's do that on the calculator. Are we capable of doing that by hand? Yes. Is it any sort of chain rule type of thing? No. I would actually multiply it out and then integrate it if it was something like this, but we can use our calculator here. Let's go to our calculator. We don't necessarily need a graph. We can just add a calculator. And I've got this. And then integrate from negative 1 to 2. And again, I could have put it in my graph if I wanted to, but I can just type this in like this. And this gives me negative x squared plus x plus 2 quantity squared dx. Yeah, where's your calculator? Get a calculator. He does think he's smarter than us. 8.1. Do I have to put a bunch of decimal places, or is it just 8.1? 8.1. If your calculator has the correct mode stuff going on, it's just plain old 8.1. So when we're talking about squares in general, you're going to integrate from a to b, and then once again, the top minus the bottom, g of x minus f of x, because that gives you a side length, and then you square it, dx. That's what we just did. Okay? And we're getting all the little squares in there. We okay with that? All right. So we're going to do the same thing here, but with different cross sections. So this says, consider a region R bounded by the same curves. Find the volume of the solid formed by rectangular cross sections of height 1. That's important because we can get the base, right? If I do this, I'm going to have these little rectangles here, right? I'm so bad at drawing this. We're going to have these little rectangles. I can get this the same way I did before, right? Which is just subtracting the 2. So here's my rectangle. I know for a rectangle, area equals base times height. Right? Your height equals 1, and your base equals, once again, g of x minus f of x, because it's just a difference in the y values. Everybody okay with that? So that means that this time I'm going to integrate. I'm going again from -1 to 2. I'm integrating area. Okay? The base is g of x minus f of x, which, do we already know what g of x minus f of x is? Yes, it is what? Negative x squared plus x plus 2. So negative x squared plus x plus 2 times the height, which is what? 1, and then dx. So if you wanted to, on your calculator here, the only difference between this, so if I grab this, I can come over here, I can get rid of the squared, and then multiplying by 1, is that going to do anything? No, but you can put it in there anyway. And then it saved you from retyping all that stuff. I went up here to where it was blue, and I hit enter, and it'll bring it back down here. And then once you're down here, you can arrow over and edit things if you want. Or you can type it back in. Like, be careful when you're editing too, but it's just another option of how you can do it. We got 4.5. Right? And it's 4.5, and what did we just find? Volume. What do the units look like on volume? Cubed. Because look at what we got on the first one, we found area. Is it 9 over 2, 4.5? But that's square units. This is cubic units. So they're different. Everybody okay with that? And we'd have an infinite number of little rectangles here that will be perpendicular to the x-axis. Yeah, that's one bad thing about editing, is if you forget to take something off, you could mess yourself up. But alrighty, let's try this next one. It says, consider a region R bounded below, same, blah, blah, blah. This says, find the volume of the solid formed by equilateral triangle cross sections perpendicular to the x-axis. So this time I'm going to have an equilateral triangle, which that doesn't look equilateral at all because I'm terrible at drawing, but we can pretend, right? We'll pretend that they're all three the same. Equilateral triangle there. To find the base, I'm going to do the same thing by subtracting, right? But here's some things you got to know about equilateral triangles. Well, first of all, how do you find the area of a triangle? Okay, so area of a triangle is equal to 1/2 base times height. So I need the base length, which I can get the base by doing, once again, g of x minus f of x. You agree with that? All right, but then I need the height. The three side lengths are the same. The height is not the same. Okay? So we can figure this out a couple of different ways. What do we know about the angles in an equilateral triangle? Well, this is 90, but what are these? 60. They're all 60, right? So if I take just if I just take half of this right here, I'm going to get a 30, 60, 90 triangle. Okay? This is my height. This is basically my base length, even though my base is over here because it's the whole side length, right? And then what is this? Yeah, half of the base. Well, we'll just do 1/2 base. Everybody good with that? So then I need to figure out, this is 60. Do you know your special right triangles? Yes or no? 30, 60, 90 triangle. You've got across from 30 is the short leg. This is 2 times the short leg, and this is the short leg times the square root of 3. Sound familiar? This comes from geometry, and we did it last year too, so. And we did it before we started trig, yeah. This what? This is 30. This is 30. So this is S for short leg. The hypotenuse is 2 times the short leg. Long leg is the short leg times the square root of 3. Yes? No? Maybe? What? Rings a bell, but it's a quiet bell. Okay. Well, here's the good news. I haven't really seen this on here too terribly much. But if I call this part right here x, then this is 2 times x, right? And this is supposed to be x times the square root of 3. So basically I can take this whole thing is b, right? So I want half of this times the square root of 3. That's what goes in here. So I want 1/2 of g of x minus f of x times the square root of 3. Because this would be x times the square root of 3. Okay? X would be half of that. That's what's happening there. You all okay with that? That's to find the height. Yeah, that gives me the height. Another way to just know what the height is that if I have this, and this is x, 2x, x times the square root of 3, then if we think back from what we know about trig, right, we've got that this is, if this is 1, then this is my 30. What is the across from 30 would be 1/2 and then square root of 3 over 2. But I don't know that any of y'all are going to remember any of that either. But do you understand where I got that part at least? I think maybe that's better. I don't know what's better for you at this point, honestly. But that just becomes a square root of 3 over 2 times whatever the base is. So let's put all this in here. It's been a long time, I think, since an equilateral triangle has been asked like this. I think that's our saving grace right there. But we're going to go through it. Because if you don't understand all of this stuff from past knowledge, then, I mean, we didn't do it a ton in pre-cal, but you definitely did it a ton in geometry, or you were supposed to. So we're going to integrate from -1 to 2, and I got to find the area, right? I find the area of the triangle by doing 1/2 times the base. So the base length, which is this, that is my g of x, which is minus f of x, which we've already figured out a couple of times is -x squared plus x plus 2, right? So I have 1/2 times the base times the height, and this is your height right here, times 1/2 times this again, times the square root of 3 dx. What did I did negative 1 to 2. Because I looked over here and I saw 1. It's these numbers, sorry. See if you can type that in, see what you get. I'm going to start over. I'm not going to go with that. Going from negative 1 to 2. And then 1 half times negative x squared, squared plus x maybe? Okay. Plus 2, y'all are probably already done, and I'm still over here trying to, times 1 half times negative x squared plus x plus 2 times the square root of 3. Dx. Cross my fingers that I did that right. I think I did. Let's move that other way. Is that what y'all got? Okay. So this is equal to 3.507. All right, semicircle cross sections. We have time. Semicircle cross sections. How do you find the area of a semicircle? 1/2 pi r squared, right? Because pi r squared is that, all right? So that means, how would I find, well, actually, what part of the circle is this? The diameter. So the diameter is g of x minus f of x. I don't want the diameter, I want the radius. How do I find that? 1/2 g of x minus f of x. Okay. And then I want to integrate, right? So I'm going to integrate from negative 1 to 2. Okay. And this is my area formula that I'm using. So it's going to be 1/2 times pi times, this is the radius, 1/2 times negative x squared plus x plus 2 squared. Check out my parentheses, okay? I have, this whole thing is the radius, so this whole thing has to be squared. And if I don't already have that distributed in there, it's going to have to have a parenthesis there too. Does that make sense? All right, and then dx. Type that in. Oh my goodness. Then stick it on there for until tomorrow. Why can I not? What's wrong? There we go. Going from negative 1 to 2. 1/2 times pi times 1/2 open parentheses again, negative x squared plus x plus 2. And then close, close, squared dx. 3.181. Okay, I got 3.181. Is that what you got? Make sure you get that. And then we are going to pick up here tomorrow. You can leave your little things. We'll just put them over here so we have them to look at tomorrow for the people that aren't here.